Quantum mechanics, often seen as the realm of subatomic particles and theoretical physics, has found an unexpected application in the natural world, particularly in the navigation systems of migratory birds like the robin. In 1975, Peter Atkins labeled the study of magnetic fields' effects on chemical reactions as a romping ground for charlatans. However, the scientific community's understanding has evolved dramatically since then. Today, we recognize that birds like the robin might employ quantum mechanics in a very practical sense for their migratory navigation. Imagine if the secrets of navigation weren't just about maps or compasses, but involved the mysterious world of quantum physics. That's what scientists believe might be happening right in the eyes of robins as they migrate across continents. Here's how it works. When sunlight hits the eye of a robin, it can trigger a reaction in a molecule called cryptochrome. This reaction splits the molecule into two parts, each with an electron. These electrons start a kind of dance, where they can either be in harmony or out of step with each other. Now, here's where it gets trippy. Earth's magnetic field can influence this dance, acting like an invisible guide that tells the bird which way is north. Cryptochromes are ancient proteins found across all forms of life, from bacteria to plants and animals. These proteins originally came from a family called photolyases, which are like tiny repairmen in bacteria that fix DNA damage caused by sunlight. In more complex organisms like plants and animals, cryptochromes have evolved beyond their original repair job. Mammals, for example, have their own version of these proteins, especially in a brain area called the suprachiasmatic nucleus, which acts like a master clock for our daily rhythms. These proteins in mammals also don't repair DNA, but are vital for setting our body's clock to the day's light and dark phases. Overall, cryptochromes have transformed from simple DNA repair workers in bacteria to key players in how living things perceive light and time, showing us how nature can repurpose its tools in fascinating ways. Scientists have done some clever experiments to test robins' quantum navigation skills. They used a molecule not found in nature to mimic what might happen in a bird's eye. When they turned on a weak magnetic field, similar to Earth's, the molecule's behavior changed, much like a tuning fork vibrating at a certain note. They also tried messing with the bird's natural compass by using radio waves, and guess what? The birds got confused, suggesting that something very sensitive to magnetic fields was at work. This isn't just about robins, though. Think of bees buzzing from flower to flower. They might be using these quantum effects to navigate. Bees use the sun's position for guidance, but there's a growing belief they might also sense magnetic fields, possibly through a similar mechanism involving cryptochrome-like proteins. What's truly amazing is that this dance of electrons isn't just simple chemistry, it's quantum mechanics at play. Electrons can be in two places at once, entangled in a way that what affects one instantly affects the other, no matter how far apart they are. This sounds like science fiction, but it's happening in the warm, wet environment of a bird's eye, not in some high-tech lab. So, next time you see a robin or any migratory creature, remember, they might just be using the universe's tiniest rules to perform one of nature's greatest feats, finding their way home or to new horizons, guided by the invisible dance of quantum mechanics.